2016, the media and social networks were buzzing with news that excited and amused the public. On May 24th of the same year, a traveler and blogger, Chloe Phillips Harris, flew CZ6011 from Urumqi to Almaty in the Republic of Kazakhstan. At the border, she was denied entry into the country because she presented a passport of a non-existent state. The state, according to the border guards, was New Zealand. This is the version told by Chloe. Not everyone on social networks was on her side, noting that it's just fantasy for hype. The official response of the authorities of Kazakhstan was also quite predictable. The girl did not have a visa. It doesn't matter who was right, because in less than a year, the academic world was shaken by the discovery, which can make us rewrite geography textbooks. And border services around the world may have to prepare themselves for the arrival of tourists not just from a previously unknown country, but from a continent unknown before. For better or worse, we're not talking about Atlanteans or some new people in general, but about a new continent. Skeptics would say, well, sure, now you're going to tell that, let's say, Greenland will be recognized as a continent on paper, and that's the whole intrigue. No, it's not that simple, and it's much, much more interesting. Today, you're going to find out where a real, not mythical, sunken continent has been found. What can we find there? Why is Greenland an island and Australia a continent? What do the kiwi bird and the elephant bird have in common? A hidden continent that has been searched for 400 years and found. Please like this video and subscribe to our channel. YouTube algorithms will understand what you like and will offer you even more interesting and educational content. How many continents are there on our planet? If you ask this question to Google in different languages, you will see that there is no clear answer. You probably learned and remembered in your childhood that there are 7 continents. But this is just you, and some people know that there are 6 of them, or 5, or even 4. So who's right? The answer is everyone. These are simply different models of understanding the issue. It all depends on where and when one grew up, what culture one was raised in, and what educational program one studied. Yes, this may come as a surprise to many of our viewers around the world, but the number of continents remains a subject of discussion. In some systems, Europe and Asia are considered a single entity, Eurasia. In others, North and South America are a single continent, the Americas. Some do not consider Antarctica a continent, claiming that it is only an island, a kind of super Greenland, and so on. So the number of continents is a matter of interpretations, construals, and conventions rather than a unified definition. Currently, the most universally recognized version is that there are 7 continents: North America, South America, Europe, Asia, Africa, Antarctica, Australia, and that with reservations primarily regarding Europe and Asia. But let it be 7, because we need something to base on. So, according to all criteria, it appears that the lucky number 7 is the maximum. Until recently, nobody thought there could be an 8th continent. Yes, until recently. But in the mid-1990s, geologists began to suspect something. First, there were timid attempts to confirm the suspicions. Then, other prominent scientists got involved. And now, in the recent few years, the scientific world has been literally flooded with the overwhelming truth. And don't think it's about recognizing a long-known Greenland as a continent. No, it's much more interesting than that. And before we unveil all these amazing things to you, we need to explain something to complete the idea of ambiguities in the definitions of what a continent is. Up until the 1960s, the definition of a continent was simple, roughly as a large area of land comprising many countries connected together without being separated by water. Things got more complicated in the 1960s when scientists studying the ocean bottoms found that the crust beneath the oceans was fundamentally different from the crust on the mainland areas. Two types of crust were identified: oceanic and continental. The oceanic crust is dominated by basalt, while the continental crust is dominated by granite. These are the most common rock types on Earth, and both are igneous, meaning they originate as hot liquids. As they cool, they crystallize and form rock. The thing is that granite is less dense than basalt, and while still in liquid form, it actually floats on the denser and heavier basaltic bulk. This explains why the oceanic crust lies noticeably lower in relation to the Earth's surface, and why the continental crust rises much higher. It's a matter of buoyancy. The average height of oceanic crust is 4,500 meters, about 14,800 feet below sea level, while continental crust rises 450 meters, about 1,500 feet above sea level. So that's how simple it turns out to be. The reason scientists didn't realize this until the 1960s is also simple. The oceanic crust lies at great depths, and we simply weren't able to get to it until the appropriate technical means were developed. That's how the first ironclad argument for defining a continent, continental crust, appeared. Scientists breathed a sigh of relief, but just for a while. Because crust is not the only criterion. What about the size of the land? Like, really, why is Greenland an island and Australia a continent? What's the minimum area for a piece of land to be considered a continent? And most importantly, on what grounds? The arguments continue to this day. There is still no generally accepted requirement for the minimum size of continents. There are even definitions that suggest that even a piece of land of 1 million square kilometers, about 400,000 square miles, can be considered a continent. But this is half the size of Greenland, which, as we know, is an island. No other way. Therefore, most scientists still tend to more weighted definitions, which offer a benchmark of 3 million square kilometers, about 1.16 million square miles as a threshold for land to be considered a continent. This is how the second argument arose. Though controversial, it's still better than just a large area of land. What next? Definitions from different angles were formed. The narrowest meaning of the word continent is a continuous piece of land with its coastline and any land boundaries forming its edge. In this sense, the term mainland Europe, the British often say simply continent, is used to refer specifically to mainland Europe, excluding islands such as Great Britain, Iceland, Ireland, Malta, and others. By the same logic, the term continent Australia refers to mainland Australia, excluding New Guinea, Tasmania, and other nearby islands. But from a geological point of view, the boundaries of the continent can be extended beyond the continuous mainland and can include the shallow submerged adjacent territory, which is called the continental shelf. This also includes islands on the shelf, which will be called continental islands in this case, since structurally they are a part of the continent. From this point of view, the edge of the continental shelf is the true edge of the continent, because the coastlines change depending on changes in sea level. Indeed, let's imagine a high tide on a flat shore that causes the water to move a dozen or so meters inland. That piece of land hasn't stopped being part of a continent, has it? In this sense, the islands of Great Britain and Ireland are part of the continent of Europe, while Australia and the island of New Guinea together form a continent. Some specialists go further, assuming that the concept of a continent can go beyond the continental shelf to include oceanic islands and continental fragments. Thus, Iceland is considered part of Europe, and Madagascar part of Africa. And finally, the scientific extreme. Some geographers classify the continental part of Australia with other islands in the Pacific Ocean as Oceania, which is usually considered a region, not a continent. Okay, there's one last thing. Suppose two large pieces of land are located very close to each other in the world ocean. Both fulfill the two criteria mentioned above. They both consist of continental crust, and each is larger than 3 million square kilometers, about 1.16 million square miles. How can we tell if they are two different continents or if they are one continent just divided by a patch of ocean? The answer came pretty quickly. To consider these two pieces of land to be different continents, they must be separated for the most part by oceanic crust, not continental crust. And that was the third argument in determining what is a continent and what is not. So again, here are the three main criteria science uses to determine what is a continent, not an island or continental fragment. It consists of continental crust. It's a large landmass of at least 3 million square kilometers, about 1.16 million square miles. And it is separated from other continents by a patch of oceanic crust. We would like to particularly emphasize the third argument. It will play the crucial and final role in the discovery our video is devoted to. You'll find out soon. This long introduction was necessary to fully understand the discovery we have finally reached. It took navigators and scientists as long as 375 years to make this discovery, and it all feels like an epic detective story. Let's see what this is all about. There is a reason why we started our story with a curious case of a tourist from New Zealand. Hundreds of years ago, these lands excited the minds of explorers. Europeans had an unshakable belief that there must be a large landmass in the south, which was even given a provisional name, Terra Australis. This belief was based on the erroneous and naive idea that a large amount of land in the northern hemisphere should be kind of balanced by no smaller amount in the southern hemisphere, or otherwise the Earth would turn over. By this time, Australia was already known, but Europeans believed that it was not the legendary continent they were looking for, and there must be another. They tried hard to find it, sending expeditions in that direction. One such pioneer was an experienced Dutch navigator, Abel Tasman. On August 14, 1642, he sailed from Jakarta, Indonesia, in 2 small ships, and pretty quickly discovered the South Island of New Zealand. 250 years passed. Scottish New Zealand geologist and naturalist Sir James Hector surveyed a number of islands off the coast of New Zealand in 1895. He concluded that New Zealand is surrounded by a vast continental shelf with depths ranging from 1,000 to 2,000 meters, about 3,000 to 6,000 feet, much shallower than the ocean floor depths of 4,000 to 5,000 meters, about 13,000 to 16,000 feet. That same year, he reported his findings in a scientific paper where he said that New Zealand was the remnant of a mountain chain that formed the crest of a great continental area that stretched far to the south and east, and which is now submerged. And finally, in 1995, American geophysicist Bruce P. Lyondike, showing great scientific courage, decided to call things by their names. In his opinion, the entire underwater area around New Zealand, which is structurally a continental crust, should be considered a full-fledged continent. And that's that. He even gave this continent a name, Zealandia. The idea struck a chord among New Zealand geologists and the public. Perhaps the hype would have faded, and the idea of an 8th continent would have vanished. Who cares about some spaces underwater? But the UN Convention on the Law of the Sea, which came into force, changed everything. The document states that countries can extend their legal territories beyond the exclusive economic zone. This zone extends 200 nautical miles, 370 kilometers from the coastline. so a country can claim rights to an extended continental shelf with all the minerals and oil it includes. If New Zealand could prove that it was part of a larger continent, it could increase its legal territory sixfold. Needless to say, there was instant money, energy, and motivation for scientific pursuit in this direction, in abundance. Different groups of scientists from New Zealand worked on the issue. Expeditions were sent to survey the area and take samples. With each rock sample collected, the case for Zealandia grew stronger. Then, a satellite constellation was added to the study, and it was a breakthrough. Using data from orbit, it became possible to map the ocean floor based on the slightest changes in gravity in different parts of the Earth's crust in the vicinity of New Zealand. Thanks to this technology, Zealandia became clearly visible, and it was finally clear that even though it was smaller than Australia, it was still huge. The New Zealand research organization GNS Science has produced 15 detailed maps presenting the continent in different contexts and from a variety of perspectives. Moreover, they show in dynamics how Zealandia separated from the supercontinent Gondwana and how it was transformed over many millions of years. The authors call the continent not even Zealandia, but Te Reo a Maui, which is how its name sounds in the language of the indigenous Maori people. A few more years later, the collaborative work of many researchers revealed even more surprising details about how the continent formed, what it was, and why it sank. For many millions of years, the planet's land surface was divided between two large supercontinents, Gondwana and Laurasia, huge fragments of the broken-up supercontinent of Pangaea. This is what Gondwana looked like. What would later become Zealandia took up a corner on the eastern side of Gondwana, where it bordered several other continents, including half of West Antarctica and the entire eastern side of Australia. It was a fairly large area, making up about 5% of the total area of Gondwana. Then, the supercontinent began to break up. Fragments of what would become present-day South America, Africa, India, Australia, and Antarctica began to separate from it. Zealandia too separated and set off on its voyage on the Earth's mantle. As these continents spread apart, some of them, such as South America and Africa, were pressed together for a long time, so they didn't change shape too much. You see, the eastern outline of South America is exactly the same as the western outline of Africa. It's like pieces of a complex jigsaw puzzle. With Zealandia, something different happened. Its shape changed quite a lot, but it wasn't the change in shape that affected the continent's dramatic fate. It was the change in thickness. Continental crust is usually about 40 kilometers, 25 miles thick, much thicker than oceanic crust, which is usually about 10 kilometers or 6 miles thick. In the process of drifting, Zealandia didn't just move, it stretched, literally like a rubber band. What happens to a rubber band when you stretch it? It gets longer in width, but it gets thinner. That's exactly what happened to Zealandia. It literally stretched wide, losing half its thickness. Now the thickness on the continental crust of Zealandia is about 20 kilometers, 12.4 miles. Most likely, the continent did not submerge underwater as if a sinking ship from top to bottom. Instead, it thinned so much that eventually, its surface was almost below the level of the world's ocean. Only the islands of New Zealand, New Caledonia, and other smaller islands remained above. And now it's time to return to the question of definitions. Remember, we mentioned 3 main criteria that scientists have laboriously agreed upon to clearly define what a continent is and what is not. And there was an intrigue and almost a drama at this point. The first criterion is that the continent must consist of continental crust. The test was passed with an excellent mark here. No one has any doubts. This was determined by Sir James Hector more than 100 years ago, and subsequent studies have just confirmed his conclusions. The second criteria is an area greater than 3 million square kilometers, about 1.16 million square miles. There's no doubt about that either. Zealandia has been measured up and down. The area of the continental crust is 4.9 million square kilometers, 1.9 million square miles. The area of the continental crust is 4,900,000 square kilometers, 1,900,000 square miles. The third criterion is that it must be separated from the other continents by oceanic crust. And this is where the real intrigue was. Indeed, Zealandia is very close to Australia. If there was no oceanic crust between them, it would appear that Zealandia is simply a continuation of Australia and should be called merely a continental fragment, but not a continent. However, Zealandia's continental status was rather quickly saved. It turned out that between it and Australia, there is a very narrow yet quite obvious layer of oceanic crust. It's only about 25 kilometers, 15 miles wide, almost nothing on the scale of entire continents. It was formed by volcanic activity, and that made it clear that Zealandia should be considered separately from Australia. Virtually no one was left in doubt anymore. New Zealand's 268,021 square kilometers, 103,483 square mile islands are just the tip. And in fact, in addition to New Zealand, there is also, so to say, Old Zealand, with an area of almost 5 million square kilometers, 1.9 million square miles, almost 20 times bigger. Although the geology of Zealandia is already clear, there are still many things unknown. The unusual origin of the eighth continent makes it particularly intriguing to geologists, and in some cases, even confusing. For example, it is still unclear how Zealandia has managed to maintain integrity while being so thin and not breaking up into microcontinents and islands. Another mystery is when exactly Zealandia became underwater, and whether it ever actually was a landmass. After all, it cannot be ruled out that it was originally mostly underwater. There is still debate and research going on. More and more evidence suggests that these vast areas were once dry land indeed, and certainly teeming with life. Then the question arises, if we explore these flooded areas, what can we find there? Perhaps remnants of ancient forests with previously unknown huge trees, or even fossils of ancient animals, the existence of which the scientific world has never known before. Logic suggests that this could be the case, and not just logic. With its mild climate at 101 million square kilometers, 39 million square miles, the ancient supercontinent Gondwana was home to a huge variety of flora and fauna, including the first four-legged terrestrial animals. And later, it was also home to the largest animals that ever lived, Titanosaurus. So could Zealandia's underwater cliffs be dotted with their preserved remains, or someone else's? There are not only speculations, but also quite material evidence that supports this hypothesis. Fossils of terrestrial animals are quite rare in the southern hemisphere, but still, the remains of a few were found in New Zealand back in the 1990s. For example, the ribs of a giant species of sauropods, a long-tailed dinosaur with a long neck. Also, fragments of fossils of a small herbivorous Hypsilophodon, and even an armored and spiky Ankylosaurus. Then, in 2006, a foot bone of a large predator, possibly a species of Allosaurus, was discovered in the Chatham Islands, about 800 kilometers, 500 miles east of South Island. It should be noted that all the fossils date from the time when the continent of Zealandia had already separated from Gondwana. New Zealand's kiwi, one of the strangest birds on the planet, adds spice to the story. This flightless creature with cat-like whiskers and thin feathers that looks more like fur has always attracted attention. It is difficult to determine right away its closest relative. Your first thought most probably would be the extinct moa bird. It does look somewhat similar to the kiwi, except that these small birds were over 3 meters, 10 feet in size, and weighed hundreds of kilograms. And it lived over 500 years ago on the same islands. It would seem that everything fits together. But in fact, it's even more interesting, and molecular genetics helped solve the mystery. The closest ancestor of the modern kiwi bird is actually the extinct elephant bird. It was also a 3-meter giant that laid eggs as big as those of the dinosaurs. The only difference is that the elephant bird didn't live here, to put it mildly. Its habitat was in the forests of Madagascar. It died out about 800 years ago. This is further proof of New Zealand's origin from the supercontinent Gondwana, and not due to volcanic activity or any other cause. However, scientists and all curious people are most interested in what rests on the submerged territories under the layers of sediments accumulated over millions of years. And there are still some difficulties with this because the depth is quite significant. Although it is still virtually impossible to collect fossils directly from Zealandia's seabed, scientists have explored its depths by drilling. The method is not as spectacular in terms of possible finds, but it is quite effective in proving the nature of life that existed millions of years ago in this area. Actually, the most helpful and distinctive fossils are the ones which form in the very shallow seas, says Rupert Sutherland, a professor of geophysics and tectonics at the Victoria University of Wellington, because they leave a record. There are zillions and zillions of tiny little fossils that are very distinctive. In 2017, the team of scientists conducted the most extensive survey of the region to date and drilled more than 1,250 meters, 4,101 feet of seafloor in 6 different locations. The cores they collected contained pollen from land plants, as well as spores and shells from organisms that lived in warm, shallow seas. If you have water which is only, 10 meters, 33 feet deep or something like this, then there's a good chance that there was land around as well, says Sutherland, explaining that the pollen and spores also suggest the possibility that Zealandia wasn't quite as submerged as it was thought. Another long-time mystery lies in the shape of Zealandia. If you look at a geological map of New Zealand, there are 2 things that really stand out, says Sutherland. For example, the Alpine Fault, a plate boundary that runs along the South Island and is so impressive in size that it can be seen from space. The second strange thing is that the geology of New Zealand, like that of the entire continent, is oddly curved. The 2 continents are split in 2 by a horizontal line where the Pacific and Australian tectonic plates converge. At this point, it is as if someone has taken the lower half and twisted it, so that the previously continuous belts of rock not only do not line up anymore, but lie almost at a right angle. The simple explanation for this is that the tectonic plates shifted and somehow changed their shape. But how exactly and when this happened is still not fully clear. Sutherland explains that the continent will hardly reveal all of its secrets anytime soon. It's quite hard to make discoveries when everything is 2 kilometers, 1.2 miles underwater, and the layers that you need to sample are 500 meters, 1,640 feet beneath the seabed as well, he explains. It's really challenging to go out and explore a continent like that, so it just takes a lot of time, money, and effort to go out and ships and survey regions. We do not know whether international organizations and the authorities of some countries have the determination to include the 8th continent in geography textbooks. But that does not change the main point. The 8th continent is a fact. More than anything else, it shows that almost 400 years after Tasman's search, we still have much to discover. Who knows what explorers will find when they reach the depths that were once the surface? Unfortunately, it's certainly not the ruins of an ancient civilization. Though, to put it in the words of the legendary poster, I want to believe.